So what do you see when you look at a fly? Do you see a pest? Do you see something that is positive and helps reinvigorate the environment by eating up rotten flesh? Or do you try and catch it like Mr. Miyagi, but fail all the time with your chopsticks? What I see is a world of possibilities. Now, looking at the example, just the eyes, the compound eye of the fly. It's not like our eye. It's very, there's lots and lots of them. And what it does is it allows them to process lots and lots of information with a large brain. Now, compare that to our eyes. A single lens, we see red, green, and blue. But as a species, we're born with certain biases. We see things, we see patterns. We've all done it where we stared up at the sky and looked at clouds. We might see animals. We might see the Messiah. We might even see the current President of the United States in there somewhere as well with his floppy hair. But this is a bias that actually has problems with us as designers because we're set in our ways and how we actually take things forward. So I'm here to tell you a little bit about biomimicry. So what is biomimicry apart from sitting, wrapping yourself in a blanket and looking out? Biomimicry is about how to develop new technologies by looking at how nature's processes and functions to develop new innovative solutions. For example, looking at cars, or flight, or biochemistry, and things like that. There's a whole world of possibilities out there just by opening your eyes and looking. Consider the humble bee. There's potentials there from drone technologies, how it senses the world and looks in ultraviolet light. Consider the plant, and how the plants communicate with each other to warn off about predators, and how they sense the different seasons, and how the roots can actually start finding water and earthing themselves towards gravity. Consider under the sea as well, the shark, how the shark is a very graceful animal, and it senses through the lateral line, and also it's sensing the electrical conductivity of fish that are in trouble. There's a whole world there of possibilities. There are interesting animals out there, bats. Well, like the phrase, blind as a bat. Well, bats actually can see quite well. Just at dark, it's a lot harder to see. So they use echolocation, which is sending out ultrasonic waves at night to avoid obstacles, and also allows them to find prey. So how are we going to use this in technology? Well, a number of years ago, researchers and engineers got together and thought, well, how can we help people with sight problems navigate around the towns and cities? And they came up and developed an ultrasonic cane that allows people to sense obstacles around them through vibrations in the handle. So then they can create a sensory vibrations walking around their cities. One of my favorite animals, you may not think so, is termites. Again, like the fly, people think termites, well, they eat houses, especially in warmer climates. But they're a vital part of the ecosystem, especially in Africa. They're also amazing builders. Now, they don't sit down at planning meetings and sit down with the developers and get the plans out and start thinking, right, what we're going to do here, we're going to put windows in. Oh, no, we need another balcony, can we squeeze another in? They work together as a team. They're superorganisms to construct these things because millions of years ago, when they evolved, specifically the Namibian termite, they evolved in a forest when there was a lot more CO2 and it was 80% humidity. And the reason why they create these amazing structures is to protect their main food source, which is a fungus. Now, this fungus likes this humidity. The fungus is a great thing. It allows the termites to collect the materials, and it actually works in symbiotic relationship. So how are designers, engineers taking this forward? Well, they're studying how the termite mound works. Because the termite mound, as it's constructed, is very much like your young children. When they're playing with Lego, they're not coming up with a solution, they're just building until things work. The termites work in the same way by putting bits on together until the termite mound is actually constructed and the hole is actually filled in. They make mistakes, and then they move on. So the structure works in a very interesting way. It doesn't, as some recent research showed, control the temperature. It's all about changing the way, in fact, that the airflow moves around to protect the fungus. And the great thing is, it allows CO2 to be leached out of the construction at night and suck in oxygen. Now, why is this important for our technologies? Well, we like building things, lots of things made out of glass, using lots and lots of energy. Now, the big issue is here, we're using lots more energy to keep things cool with changing climates. We're finding places are hotter or cooler at different times of the year. By looking to termites, they're finding ways to actually create buildings that will minimize the use of technologies and using high energy technologies. That will allow us to create buildings that are actually more adaptable to where they're based instead of a one-size-fits-all. They're also creating a brick inspired by the termite fungus as well. Now, this brick will allow you to put it into museums and hospitals because the brick will actually allow you to control the moisture levels. Now, one of the great things about when you're looking to biomimicry and speaking to lots of people is who's in charge? Is it the fungus or is it the termite? It's a bit like looking to the human body. Who is in charge? Is it the gut microbiomes? Or is it us, the big brain, or the little brain, depending which way you want to look at it? Now, when you're out there building, designing, creating, we look around for ideas, and it's natural. Why don't we look to the natural world? But instead of just looking at its surface value and looking at the patterns and clouds and bark and that to take it a superficial way, why not delve a little bit deeper? Look at the way the mathematical formula of the leaf transports fluids around the leaf. Look at the structure in there as well. Look at the way that it processes the solar energy through photosynthesis. There's a multitude of solutions out there. Now, I'd just like to end on an interesting quote by the late, great Stephen Hawking. And it's to do with the town Monza in Italy. And seemingly, the town banned people from owning circular fish tanks because they said that the fish would have a distorted view of the outside world. Now, how do we know that we've not got a distorted view of the world? Thank you.